Hogwarts Castle, a 5-inch gauge locomotive, part 19, making and fitting the cylinder cladding. The first part of the job is to flatten out the old cylinder cladding, because I'm going to use this part as a template to mark out the positions of the holes on the new piece of metal. In this video I'm only going to show making one side. Obviously there are 2 cylinders, so I need to make 2 of these, so in this video I'm only going to show me making one side. This is a pot of marking out blue, and I really don't know how I managed without this stuff for so many years. This was sent to me by a viewer called Norman. Thanks, Norman. As you can see from this clip, I already have 2 pieces of metal for the new cladding, and it's thicker than the old stuff. And to anyone out there currently building a steam locomotive, it's a good idea to make the cylinder cladding as thick as you can handle. That reminds me of a girlfriend that I used to know. On this piece I've only marked around the edge where I'm going to be marking the hole positions, but on this other one I thought it would be more artistic, and I call this one a study in blue using Norman's marking out fluid. And on this second side I thought I would just use up what was on the brush, so I applied the colour all over the steel plate. Now the marking out fluid on the first piece is dry, I'm going to clamp one of the old pieces of cladding to the new piece of metal, and then I can mark the positions of the holes by poking a scriber point through the original holes, and applying the logic that the original cladding fitted to the cylinder perfectly. With a bit of luck this should do the same, although it is thicker, so there will be errors introduced. At this point it's worth mentioning that when I went up to Blackgates Engineering and got Matt to cut me this cladding on the guillotine, I asked him to cut me 4 pieces, so I can actually make a thorough mess of 2 of them and still get out of it. But I'm going to try really hard not to do that. I'm currently checking the alignment of the marks using a ruler and marking the positions of the holes for the draincocks. I'm going to drill the draincock holes a little bit bigger than the holes on the original cladding. It's always a good idea to leave a little bit of clearance on things that get hot and then go cold. In this clip I'm using my micrometer to take the original measurements of the diameter of the bushes that hold the draincocks. And now it's over to the drilling machine. I'm using a hole cutter. These are really useful things, and these are from China, and at first I thought, oh well, what they're going to be like, but they really are very good. If you look carefully you will see that I've wrapped a big piece of cloth around the piece of steel in case the drill grabs it. But this cutting tool didn't grab the work and spin it round. I only used the piece of cloth when I was using the big hole cutter. There isn't enough leverage on this very small centre drill to spin the piece of work around. Quick health and safety warning, just be very careful when you're drilling holes in pieces of metal. If the drill grabs and spins the piece of metal and it's sharp, you will be injured badly. Also, the piece of metal would drop onto the floor along with your fingers, and then it would be quite difficult to pick up the piece of metal. You have to think ahead in this job. In the outside part of the workshop I now have my small bending rollers in the vise, and I'm bending the part to suit the dimensions of the cylinder. And how do I know how much to bend this to fit the cylinder? Well, I'm looking at the cylinder through the door, and I'm using my calibrated eye to bend the new piece of cladding to accurately fit the cylinder, and here it is. And what's more, I got it right first time. I'll put it down to beginner's luck. I have to take a little bit of metal off this part, and once I'd done that I cleaned up the entire part using some Scotch-Brite. And in this clip I'm holding the cladding firmly to the cylinder to make sure that all the small holes line up perfectly. The holes around the draincock bushes are a bit of an anomaly, but this could be that the draincock bushes are not in exactly the same place on the cylinder, but it's more likely that they weren't in the correct place on the original cladding. This is not a major issue because it's very much underneath the engine out of the way. Now this is the scary part. I have to drill a hole tapping size for 8BA using the existing holes in the cylinder casting as a guide, and if the drill breaks here then I have a problem. I'm using my battery operated Proxon motor tool for this, and this is a wonderful gadget. For drilling this cast iron I don't want it to go really fast, but I've turned the speed up and I'm putting a lot of pressure on it, which keeps the speed low, and it doesn't burn out the drill. Well, it did once, but I resharpened the drill and now it's drilling okay. I don't mean that the drill burnt out as in the Proxon motor tool, I mean the drill bit. So that's one hole drilled, and now is the even scarier bit. Tapping an 8BA hole in a cast iron cylinder where you don't really want it to break off. So the term "a touch like a midwife" springs to mind. You have to be firm and gentle at the same time. These are the dome head 8BA bolts that I'm going to use to secure the cladding to the cylinder, but unfortunately I only had one of them and that was damaged. I've used it here just as an example. To temporarily hold the cladding, I'm going to use some cheesehead bolts that I have. The way I'm doing this is to drill the hole, tap the hole, fit a bolt, move on to the next one, drill the hole, tap the hole and fit another bolt, etc., etc. Here's a close-up of the tapping process at a higher speed than normal, just to make it look more scary. This is a very small tap and it will easily break. In this clip I'm showing you that the bolts are very small, there are only about 6 threads on them. And would you believe there are actually 8 holes in this cladding, and it will be fitted with 8 bolts to hold it to the cylinder. Drilling and tapping these holes is quite simple, but the 2 holes on the bottom side of the cylinder are going to be really difficult. In this part of the clip I'm showing how the small bolts hold the cladding firmly to the cylinder. Now comes the difficult part. This was very tricky to complete. It was difficult to drill the hole, and I'm being really careful with the tap because it's not quite going in at the perfect angle. When I make and fit the other piece of cladding to the other side, I'm going to leave out the bolts in the bottom part. They really are overkill and they're not required. Here's the finished job on one side and I think it looks okay. And because this cladding is made from thicker sheet steel, I don't think it will dint easily like the other stuff, so it won't need filling. That's it for this video. Thanks for watching and I hope you found it useful. Please take the time to visit my Mainsteam Models website. Click on the section of the website that says Video Playlists. And by doing that you will find it very easy to find other videos that you may like to watch.